Hello friends, welcome back to my YouTube channel Code with Dharmaveer. In the previous video, we have learned about big of notation and the various cases for the big of notation what we have. Now in this video, we are going to learn best case, average case, worst case analysis. So this video is going to be a very important video from interview point of view. So don't miss the video, watch the video till end. So we are going to start here now. In the introduction, we are going to talk about, we have learned the time complexity in the previous video and a big of notation. But here is the big question. Does the algorithm takes the same time? Obviously not. The algorithm don't takes the same time. Okay, always. So that's why today we are going to learn the best case, average case and worst case analysis. One of the most important concept in for the coding round and coding interviews, and that is being asked in the interviews for the real programming world. So, why this concept matters? This concept matters a lot because interviewer does not ask you what is complexity, what is space complexity. They just ask what is the best case, what is the worst case, and what happens on an average. If you understand this video, then you will be ahead of most of the beginners. So, the basic idea is very simple. The best case, average case, and worst case describes how an algorithm behaves for different inputs. So, best case is basically algorithms run fastest, average case is algorithm runs normally, worst case is algorithm runs slowest. So, the basic idea is that we analyze the performance based on the input arrangement, not code change. So the key point to be noted here is that we are analyzing the performance based on the input arrangement, not the code change. Real life analogy, or we, if you want to relate it to real life example, imagine you are searching a name in a class list. You have a role list or you have a class list, and then you are searching in the name. So at name at the top is your best case, right? You because you find it in the one go. Name somewhere in the middle, it's average case because you have to move on from one student to another student and so on. But the name at the end is the worst case because you have to traverse from starting till the end. So it's not advisable, it's not acceptable most of the cases because worst case nobody wants, is not acceptable. So single loop is here O of n. Suppose we have a loop that runs from 1 to n. So if the loop runs for n equal to 5, loop runs 5 times. If n equal to 100, then loops runs for 100 times. So if n increases, the number of operation increase linearly. It's very pretty simple. So that is basically single loop O of n. If the input size increases, then the number of operations is going to be increased linearly. The number of operations grow directly with the input size, right? And the final conclusion here is time complexity is O of n. Analogies, if you want to relate to real time or real life analogy, that is checking every student attendance in a class. More student, more time is required, right? If the input is more, then more time is required. Now comes the nested loop. So for the nested loops, you have the complexity as complexity as O of n square. So now imagine you have a loop and inside you have another loop. So both the loops running n times. The outer loop runs n times. For each outer loop, the inner loop runs n time. That means the total number of operations would be n into n, right? The outer loop is going to run n times, then inner loop is running also running for the n times. So the total operation would be n into n. So that's how for the nested loop you have time complexity as O of n square. You have a loop I equal to 1, I is less than n, I plus plus, and you have inner loop j equal to 1, j is less than n, j plus plus. So you have this time complexity for this kind of a nested loop as O of n square. This is the example. If you have, and if your sample size is 3, then n into n, that is 3 into 3 would be 9 operations, right? But if n is 10, then 10 into 10 will be 100 operations. So for every single iteration, we are doing n more operations, right? So the final conclusion is that the time complexity is O of n square. And analogy is, if you want to relate it to real world example, is comparing every student with every other student. So that is what the n into n operation. Now we have a loop that halves every time every input, that has a time complexity as O of log n. That means if you have a while loop, that is n is greater than 1, and n value is decrementing by 2, every decrementing by half, right? N equal to n by 2. So that is basically every time the input value is going to decrement by half. So here, instead of increasing or decreasing by 1, the input size is reduced to half each time, right? So if you have number of n equal to 16, if you have sample size n equal to 16, then it's going to decrement every time. You have 16 as, then after that you have 8, then you have 4, then 2, then 1. So total step size will be 4. Even if n comes larger, if it's 10 lakh, the steps are still small. So every time the input is divided, right, and the growth is logarithmic growth. So final conclusion for time complexity is O of log n. An analogy, if you are to relate it to real world, that is searching a word in a dictionary by opening a middle page. So every time you are going to open the middle page, then each middle page each time. So you are searching a word in that. Comparison summary is basically uh, single loop grows linearly, O of n. Nested loop grows very fast, O of n square. Halving loops grows very slowly, O of log n. If this video helped you even a little, please hit the like button. Subscribe to the channel for complete Java from beginner to advanced. Please hit the bell icon so that you don't miss upcoming Java videos. Happy coding for you. See you in the next video. Till then, happy coding.